Today we'll be learning a little bit about handwriting recognition, a technology that is used primarily in mobile computing and how deep neural networks are involved to make these sorts of applications possible. Today we'll be learning a little bit about handwriting recognition, a technology that is used primarily in mobile computing and how deep neural networks are involved to make these sorts of applications possible. First, what is handwriting recognition? Most people have probably encountered it at least once, but haven't given it too much thought. Unsurprisingly, handwriting recognition is just taking in handwritten language user input and generating a text-based output, such as a text file or other document. These sorts of technologies make it easier to share notes with fellow students or coworkers, or quickly search your notes for a specific topic or phrase later. Additionally, studies have shown that students who handwrite their notes tend to retain significantly more information compared to other methods, so handwriting recognition technology can help students with poor handwriting get the best use out of both their time taking notes and their time studying those notes. Handwriting recognition technology also helps in the medical field and in field research, where professionals are free to input their observations in the quickest and most natural way for them, but still have a digital record that can be uploaded to a records database or whatever other digital system they might typically use. This is especially useful considering the poor user interfaces that are common in these types of enterprise applications and the fact that many of these professionals outside of computer science find those applications extremely frustrating to deal with. Before we jump into the heavily technical side of things, let's talk about the two different types of handwriting recognition and what they mean. Online handwriting recognition refers to recognition that takes place in real time as the user is writing. This sort of handwriting recognition analyzes the trajectory of strokes being made to help predict what letter the user is currently writing. An example of this can be seen on the right. Offline handwriting recognition happens asynchronously and thus does not have the luxury of analyzing stroke data to help in the conversion to digital text. Because of this extra hurdle, offline handwriting recognition is often considered the more computationally difficult of the two. Okay, so how are computers capable of recognizing human handwriting? Well, the answer is neural networks and machine learning, and both of those are built upon the foundation of perceptrons. A perceptron is an algorithm for supervised learning of binary classifiers in which elements are processed and learned one by one. A perceptron is most easily understood by breaking it up into four main parts. There are input values, weights, the net sum, and an activation function. The input values are simple to understand, and it is just the set of data you would like to provide to the algorithm. Weights are also pretty simple and just represent how much each of these input values should be considered while calculating the net sum. Of course, then, the net sum is just the sum of the input values multiplied by their weights. Finally, the net sum is applied to the algorithm's activation function, and we get our output, which is either a 0 or a 1. We can see an example of this on the left. x1, x2, and x3 are our input values. w1, w2, and w3 all are our weights. These are combined to get our nice purple circle, which is our net sum, and that net sum is then applied to our activation function, and we get y, which is our output. Finally, we'll get into the types of deep neural networks that are used for handwriting recognition. One of these is multi-layered perceptrons, where the output of one layer is the input for another in a single directional graph. Each of these layers, aside from the first, has a nonlinear activation function. Another common type of network in this field is called a convolutional neural network, which is a perceptron used for cognitive tasks like image recognition and natural language processing. The distinguishing factor in these types of networks is that some of its layers, but not necessarily all of them, use a convolution, which is a specific type of linear operation where the input is two functions and the output is a third function that describes the relationship between the two input functions. Finally, hidden Markov models have often been used for handwriting recognition. A hidden Markov model is a statistical model used to predict the future state of a system using probability and data on the current and past states of the system. Okay, but how do these types of networks help with handwriting recognition? Well, luckily, handwriting recognition is done linearly, so computer scientists are able to analyze features one by one in succession. In addition, as we can see on the left, sometimes an algorithm may come up with multiple words for an image that are all equally possible. However, these technologies are also able to use data from large vocabulary continuous speech recognition or natural language processing in order to analyze the sentence as a whole and choose a word that makes for much more sense in context. The result is a piece of digital text that computers and people everywhere can understand, and that's all thanks to deep learning. It's all thanks to machine learning and deep neural networks.